Hey everybody, it's Tuesday, it's 3 o'clock. That means it's Tech Tuesday. Today I'm going to be continuing on my series on PreEqualization Analyzer, our DOCSIS PNM tool, and I'm going to be talking about some of the new features that are coming out in version 5, which will be rolling out shortly. Be right back. Thanks for joining me. I'm Rick Uzzi here with Zquorum, and again, continuing on the PNM series, DOCSIS PNM and our PreEqualization Analyzer tool. So many of you that will be watching this are current users of this product, so this would be specifically for you to show you some of what's coming up that's going to be new. Lots of things look different, and then there's some new features as well. But also, if you are just tuning in because you happen to find this because of the topic, DOCSIS PNM or Proactive Network Maintenance, this is a tool that applies PNM principles, so it uses the pre-equalization coefficients in cable modems and the CMTS and how that adjusts those readings to improve the, well, pre-equalization will improve the signal as it looks to the CMTS from the cable modem, but then also we can leverage that data and determine where and what kind of upstream impairments there are in the cable plant. And then there's other things now in PNM, now that it's built into the latest DOCSIS standards that we can leverage with downstream and RXMER and some other things. So I'm going to be talking about some of that today. So let's get right to it here. If you're watching and you have questions, feel free to type those in, or comments, whatever. Just type those into the chat in YouTube, and I will cover those as I can. So here we're looking at the dashboard. I showed this last week. I showed that you've got the different widgets on here and what they do. So you've got your cable modem trends over time and cable modem status over time. You've got your standard correlation groups, which I believe I showed an example of that last week, but I'll probably pull that up again here in a minute to show that just one more time. So I think I kind of touched on that at the end last week. You've got your spectra impaired modems. Those are your downstream impairments from individual modems that are being tracked here, where we're looking at the full band capture signal from those modems. So we're looking to see what kind of impairments they may have. The program will do some calculations on what that signal looks like and then try to identify some of the impairments like adjacency, suck out. You can see your resonant peak, wave, tilt, those kinds of things. And we've got the worst ones showing up here. Daily modem status. These are your critical. This is your critical modem action list. This might be where you would start with if you're going to start looking at individual modems, because these are the absolute worst ones to look at, and kind of going in order that way. And then as we go down the page, we've got our work order list. If you put in any work orders through the application that show up here, your birth certificate list. These are devices that you have installed, so to speak, and then this will take a snapshot of the readings at that time and create a birth certificate that you can always refer back to, and that way you can know that the modem looked good and what it looked like the day it was installed, or at the time it was installed even. Modem watch list, which I talked about. This is where you can put modems that you want to kind of keep an eye on. So this would be, for example, if you've got a particular modem and you want to make it easy to find, you want to find it later, you can just pop it in here and it will easily show up. And I wasn't sure about this last week, this rapid poll, and I got an answer on that. I believe is the correct answer this week. So normally the devices in here, if they're red, are polled every 2 hours. If they're not red, if they're just looking okay, or yellow or green, I guess, then they're not polled every 2 hours. They're polled. It takes a little bit longer. I'm not sure what the interval is there, but if you put a modem here in the watch list that is not red, like let's say you just want to keep an eye on it, but it's not one that's already red, you can do rapid poll, and we'll poll that device during the same interval that it would a red modem. So it does it every 2 hours. So that's what that rapid poll is. And then what I'm going to be talking about today, in addition to some changes in the map and how that's used, is your correlation groups that we're adding to the application, a full band capture correlation group and an RXMER correlation group. So I will explain those in just a minute. First, I wanted to talk a little bit about the map and what has changed there. So again, I mentioned last week that to get over to the menu, that a lot of the stuff was up here before, but to get over the menu, just hover over that, and then you've got, we're on the dashboard right now, you've got your map, CMTS overview, install cable modems. Some of these things you can do right from the modem page, install the cable modem. This would be your upstream analyzer and your upstream monitor. So this would, I'm going to be showing that next week. So there's some changes in the upstream analyzer and upstream monitor. That would be reading the spectrum directly from the CMTS live and then displaying that on the screen, and then we also capture that historically as well. Leaderboard, that would be if you want to gamify. We talked about that a little bit. Get some reports in here. I'll probably show some of those next week. Geocoding, where you can actually go in and geocode. A lot of times when somebody signs up with us and is using this, and if they have TrueVision with us, we geocode that stuff automatically and it goes in here. Sometimes we may need to geocode things separately in here, and we can do that there. There's admin settings, monitoring, configs, and that kind of thing. But I'm going to click on map now, bring us to the map. So you can see it's a full-size map, and again, when I go away from this, that just retracts. So here's my map, and what's different, you'll notice there's nothing on there, but if we give it a second, some things pop in there, some of the icons, and then we see that we've got a CMTS here. And if I had more than one CMTS, and I actually do, I've got 3 CMTS that are in this application, but this is our demo. So the only CMTS where I actually have addresses in would be this one. And these devices, as I mentioned last week, don't actually exist where they show up in the map. They're somewhere off in the northern United States, not here down in the south. We just took that data and we put it on the map and we gave them some fake names, that kind of thing, so it's a little bit easier to demonstrate some things. So right now it's showing that I have one CMTS. If I had multiple, there might be one here, might be one there, etc. So there's a couple of ways that you can drill in here. So before, if you went to what was called the detailed view, that would bring up the map, and then you'd have all of your modems pop in at once. But now we show you the CMTS, and then you can either scroll in with your mouse, and as I do that, you'll see eventually, whoops, there we go, I get a big group of nodes. And as I scroll in further, I then see eventually, right about there, it's going to change to the modems, kind of like you were seeing in the old detail map. Now I've got a group of modems that I can see, and I can drill in further and get to those. If I scroll back out again, I see the node view again. If I scroll out further, I see the CMTS eventually. You can also double click on these things, so I can double click on the CMTS, and that's going to bring me to my nodes. And then I can double click on the nodes, and it'll bring me to that. I'm going to go back actually. Once you double click, I'm going to try, yeah, it actually came back to the CMTS. One thing I forgot to mention is you can click on this, like let's say you have 3 or 4, however many CMTS that are showing up in the map. You can click that, and that will give you some information. Here's some summary information, so you can see the CMTS health, how many green modems you got, how many yellow modems, how many red modems, any invalid modems. Again, that would be, as I mentioned last week, that would be modems that we're not able to connect with for one reason or another. There's something that's wrong, or the modem is in the UDP string that we're getting, or the modem is so impaired we're just not getting the data that we need to even classify it as offline or online, and then what color it would be. So then we've got our offline modems here. So we've got that information, and same thing if I double click on this CMTS, and then more importantly, I can click here. Actually, yeah, I can click here and I can get information about this node. So that would be, again, your node health, and then you've got your green, yellow, and red modems, and invalid modems, and offline modem count. You can there's always this zoom to here where you can click that and it will zoom to it. So now it's actually brought me in even closer to that particular node. And the other thing that I can do if I double click this node rather than scrolling in, I can still scroll in and see the devices that are most likely associated with that node. But the other thing I can do is I can double click that, and when I do, notice there's no button up here, but when I double click that node, a rescan node button appears. So this now would let me rescan any of the devices that are on this node. And in this case, I'm only seeing 2 show up here, but again, these devices really don't exist where it shows that they exist. So things like this are going to look a little bit odd here. So that just shows you that you can rescan that node if you want. And that's a way, again, to drill into devices that are on a particular node. Makes it a little bit easier. Let me go out here. Once you get in this node view, when you scroll out, you don't get any other nodes or the CMTS. It's basically you're in this mode right now. You're in the node mode, so to speak. So you're only going to see devices that are on that node as long as you are on there. I'm going to go back out to the map and pick a different node that's got more devices showing on it. So actually I've got to go back to dashboard and go back to the map. So again, I'll wait for the CMTS to load. Take just a second for the map to complete, the buttons to show up. There it is. So again, I'll double click on that, and that will bring in my nodes. And I think I'll scroll in a little bit here. I think I'll pick one of these that have probably got more devices showing like they're on there. No, it's not that one, is it? Let me go back one more time. Which one did I pick? I'm not even sure. I just wanted to show a feature. I want to show how this map is now, or how the table is now map-centric here, because that's pretty important. It's very different in how it works from the current version that we have, version 4. So again, I'm going to go into the nodes. I'll try this one. I don't think I clicked this one, so let's double click that. That's got a few more there. Okay, so again, this typical node that might be clustered together a little bit more, this being not where these modems really exist. But I wanted to show you now, to get to the table data that you may be familiar with, what you do now, again, you start from the map, and then over here you've got your show and hide data. So when I click that, it's now going to show me the data for these devices. And in this case, since I'm in the node mode, so to speak, I double clicked on that node, it's only showing me the devices on this node. So you see here it says items on page 10, and then it shows, you probably can't read this, this says 1 out of 10 of 11. So there's actually 11 modems supposedly on this node. And I can go ahead and click here. I can show 10, 25, or 100. I'll just click 100 or 25. And when I do, you'll see one more, the last device showed up right here. So the other thing that's important to know that's different here is as I move on the map, you'll notice this list isn't changing right now, so I haven't really moved away from my 11 modems that are in this node. But as I move away, as I'm scrolling around the map, I'm going to move in this direction. If you watch that table on the right, you see that it changes. So now I've got 1 of 8 devices showing up. So it's basically, pretty much showing you just the devices that are appearing in the map pane. So it's pretty close. 1, 2, 3, 4, 5, 6, 7. Saying there's 8. There's probably one other one nearby that's in the map. Now it's saying there's 10. So you see there's 4 there, 5 there. So again, there's one more somewhere that's real close, close enough, I guess. So as I do that, if I get to the point where I'm down to, now I've just got 1 appearing, and that's right down there, right there by the lake. So I've just got 1 on my map that's appearing. So that's an important difference in how the map works. And that works regardless of what your view is that you're using on the map. So again, right now I'm kind of in what I would call this node mode because I can't get out of it without going back to the main map. So if I hide my data now, I open the map back up. And again, if I scroll out on the map, I'm going to continue to see only the devices on this node when I've double-clicked the node to get here. But I'm going to go out again. I don't think there's a way to exit out of this without going back to the dashboard and then clicking on the map again. I guess I haven't found that. So go back, and again, my CMTS is going to load. And this time I'm going to scroll in, just scroll in on the map without double-clicking I can double-click the CMTS. And I bet if I double-click the CMTS, if I have more than one CMTS, I haven't tried this because I don't have access to anything, or at least not on here. I bet if I double-click a CMTS where I've got more than one CMTS on the screen and I double-click one, I would imagine then, as I scroll out, I will only see that CMTS. So if I double-click that CMTS and I scrolled out, I wouldn't see any others that might have been around here that I didn't click on. I would suspect that's the case. In this case, I'm going to zoom in. And again, if I go to a node, let's try this one this time. No, I'm not going to go to a node this time. So now I'm just going to scroll in. And when I scroll in, I see all devices. So all devices on all nodes are now going to appear. Those there, and some of these over in this area here that we've got clustered. So they're all on the map. And the same thing goes for the data table. So again, if I've got this showing on the map, at least when I click here, I'm not sure about those that are covered, probably not. But now it's saying that I've got 235, so 1 out of 235. Again, I can change this to up to 100, and you'll see now I've got 100 devices that are all appearing in that table. And as I go this way, looks like it's reduced. It's 139. Actually, it's going up, sorry, because I'm adding more that were off of the map. So I've got some up at the top there that those were probably in there, but as I scroll, now I'm at 172, 146. So as I move around, depending on if I'm losing or gaining devices in the map, you're going to see that that number changes. And as I come way over here, you'll see it's down to 113, if you can even read that far, 30, 11, and then it looks like I've got one lone device over here that's not really there, but that's one device that we stuck on the map for some reason right here. So as I go to that one, again, I'm down to one device just appearing on the map. And as I go back the other direction, same thing happens. So again, very map-centric as far as looking at the data. So as same thing goes if I scroll in, it should, I would think, reduce. Yeah, now I'm down to 48 that I'm showing just in this particular area. As I move around, that changes, but if I scroll in even closer, as close as I can get, probably. Now I'm down to 18. Scroll in further if I can. So you see basically what's going on there. So as you're looking at a particular area, devices on there, it kind of limits what you're seeing, which is good because it reduces some of the noise of having all of that data on there. So that's a big change with the map. Just to review from last week in case you missed it, we've got the legend over here now. So this shows you all the different types of, all the different types of, well, I guess when I move that, that's going to go away. What these pins mean. So you've got your bonded channels with a B right here in the center of that. If it's got this shape, it is a full band capture device, capable anyway, full band capture capable. It's got more of the teardrop, it's not. And then you can see obviously red, yellow, green, invalid, and offline as far as your colors. Different devices. And what else do we have? Oh yeah, selected modems, just as a review. When you select a modem, it will get the arrow over the top and the little circle on the bottom, and it opens up this here. I can close that and it will still say, no, it won't actually. So that shows me that's selected. And when I move around the map, that will stay that way unless I come up and click again, then everything goes away. So just be aware of that you can move if you drag. But if you click, it goes away, and now you might lose where your modem was. You can always, if you're clicking and dragging and moving around and you haven't gotten rid of that, you can always hit zoom to, and it will take you back to the device you were looking at. It looks like it zoomed out for me, but it did center it, and I've still got the little arrow over the top. What else on the map? Oh, a couple of things. I think we brought back something that I believe was gone. I never even knew it was there, but then I saw in the release notes for this that it was something that was in one of the versions of version 4. I'm not sure if it's a current one or if it was a previous one. It was probably a previous version 4, where you've got this draw menu, and you can draw a polygon. So I can click that, and let's say I want to draw a polygon around these modems right here. I don't know why I would, but maybe I would. So I can start by double clicking. No, I can start by clicking, and I can draw my lines around this here and there. Oh, I guess I had to be more, I guess I needed to be more thinking about my polygon. Oh yeah, you can do it this way. So let's say it's these devices that I want to put in my polygon right there. Double click, and there I've got it. So that has, and then I can give it a name. So I can call it RX modems. And I guess I save that. So that is now a polygon, and that will always stay on the map until I delete that polygon. So as I move around the map or I do other things, scroll out, whatever, that polygon will remain there. So that's just a way of finding a group of modems, maybe that you want to concentrate on, you want to find them again later, or for some reason, again, I don't know what, I'm sure there's different kinds of use cases for that, but that's kind of a cool feature that you can do that, and you can name it. It tells you the square mileage right there that you've got. And I can, to get rid of that, all I have to do, I think, let me see, do I double click it? The center map on, what do I got here? Oh, I can recenter on it. There we go. And draw a polygon. I'm trying to remember how to get rid of it. There is a way to delete it. I deleted it last time because I was going to demonstrate this, and I can't remember what it is. It's in there somewhere. That's just a MAC address there. So anyway, you can delete this, and I just can't remember how right now. excuse me, the other thing that we have is measure distance mode. So that would be useful. Like let's say I want to know what's the distance between this red modem and this green modem. I can put measure distance mode. I can go to here, and I go to here, and now I've got that distance, and it's telling me that it is 0.24 kilometers or 0.149 miles. So we've got that little measure distance mode here on the map. Can uncheck that, and that goes away. See anything else here? DOCSIS devices. Oh yeah. This is showing me. This is just showing me basically. It looks like. I wonder if this is. I'm going to move this map and see if that changes. Yeah. So as I move that, the map this changes. So this is just showing me on the map what I've got as far as full band capture modems. I've got 49 that are on here. I've got 31 red modems, 61 yellows, and 25 greens. And again, this is all based on what is appearing in the map approximately. So you can see now that's changed to 17 red modems. Go up a little further. Now 7 and 13 full band capture. So we've got that there. That's going to be here's your search right here. You can search for a modem by MAC address, last 4 characters, and you've got all your other search items that would be available here if you wanted to look for street address, fiber node, even the CMTS or IP address numbers. So you've got on the map, as before, we've got different layers. So right here I've got full band capture QAM capacity. I am actually going to show this next week. So I think next week will be our last broadcast on this. But one of the things that's in here is the ability to do capacity planning for DOCSIS 3.1. So we take some of the full band capture data and we process that and determine which devices could be supporting a certain QAM modulation for DOCSIS 3.1, and I will show that. But that's a layer that you can put on the map, and then it's very easy also from the map to bring those up, or actually right here. So once you process that, then you bring them up right here in that particular layer. We've got FBC correlation groups that you can pull up. You put as a layer right there, and it tells you any that would maybe be in here. If there's really one there, I'm going to go ahead and look at it. I'm going to show a different full band capture correlation group because I didn't have anything good as an example on this particular demo database, so I don't see that there. So I'm going to go back to this. You can show active devices, cables, passive devices, and poles. And in order to do that, so in other words, we can do a strand map overlay on this map. It's something that it's not part of it when you bring it up. You have to send us the strand maps. They have to be in a digital format. I think we support most digital formats that they would be in. But we can do that. And then when you do that, if you were to click on your active devices, cables, whatever, and you could click them all, and then you can overlay, and you see it says no data available for showing poles. Okay. I don't think there's any of this other data either in this particular one. So, but when we have strand map data in here, then we can overlay that, and then you can see, which is really nice when you're looking at especially correlation groups, especially the upstream correlation that gives you an echo cavity distance. Then you overlay the plant maps, and you can see, okay, well, where are my amps? Where are my taps? Where are my splitters? Whatever might be in the plant. What does my cable look like? How long is that piece of cable? Where is it? And that way, when you're looking at that echo cavity, you can kind of get an idea of where the issue is. And again, the distance here, the little distance thing can help you. So as you look at the distance, where'd it go? I don't know, I got lost on here. Close that. I don't know how to close this thing here. Don't know how to close this correlation. Hide map? I don't want to hide the map. Anyway, you saw me measure the distance before, where I can measure the distance between two devices. So if you're measuring the distance of you can measure the distance of an echo cavity based on the last good modem and the first bad modem, and you get an idea how long that is. You can see how long the cable is in that particular part of the plant, distances between actives and passives, and those kinds of things. Gives you a really good idea of where to start looking for the problem. So let me go back to that now that I'm kind of lost in here. I haven't done all of this in one spot, so I don't know how to exit out of here. So I'm going to go back to the dashboard, and I'll just look at a standard kind of correlation group that you would probably already be familiar with. I can't remember which one I picked. I'm going to pick the first one. And again, I just got lucky that some of these modems are showing as they're correlated, even though they're not really at the addresses where they are. So the application is looking and saying these devices are geographically close to each other and they have a similar signature. You'll notice that my polygon is still there. So similar signature. A lot of times when you get a correlation group, these lines will be really, really close together where it almost looks like it's one line. You can see a little variation here and there. In this case, again, these modems are not really on the map where they are, so it may be that they're really not correlated, but it's showing up like it is in this particular demo. So I've got these 3 blue devices right here. It looks like I've got 1, 2, 3, 4 lines. There may be another device somewhere close by that it's saying is correlated. And again, what this is doing is it's looking at the in-channel frequency response and the tap response, and it's saying for these devices that are close to each other, nearby, the response is very similar. And again, in a real correlation group, this would be tighter. And the taps would be closer to being the same. Right now I'm looking at, let's say, 4 different devices, and it would show you on the map where they are with the blue color. And a lot of times they're going to be, in a correlation group, they're going to be closer together because they're all kind of in the same line and they're all experiencing a problem from the same impairment. So you might have, you know, like several devices on this road, and then you've got your first good modem and your first good modem and your last bad modem, or maybe the other way around. And you kind of know that the problem is going to be somewhere in between. And like I say, you could you could measure the distance between those, distance mode. So you might say, okay, well, how long is it between these 2 devices? And you get that information. And the other thing that you do is you can look at the devices that are in the correlation and get their, let me see, I'll bring the table here. These are the correlated devices. So you can look at the devices and get the echo cavity distance. Let's see if I click on this. I'm going to get out of this mode here of drawing. So if I double click here, oh, I'm still drawing. Stop it. There we go. Turn that off there. Okay. So I can open the device and I'll see that it is, first off, it tells you, again, as I showed last week, when you open a device, it pulls up whatever issues you have here. Like it shows me in this case, it's got a micro reflection level, and it's showing me that's part of a correlation group, this one that I was just looking at. So as I scroll down, I see information about this particular customer. I see the downstream power and MER information, and here I see my PreEQ data, which is my ICFR chart and my taps here, digital taps. And then down here I've got my in-home impairments, which it doesn't look like there are any. It's awfully close right here on one of these, on that one I guess. And then I've got my outside plant. This used to say TDR here, and it used to say VTDR here, virtual time domain reflectometry, that's hard to say. And then just without the virtual right here. You notice I avoided saying that again. So I've got my outside plant information here. It used to say VTDR, but now it says outside plant, a little bit more intuitive, and your in-home or near-home kinds of issues right here. So a lot of times this will be a distance of like 50 feet, 70 feet. But here you've got your longer distances. So this is showing 295 feet on one channel and 344 on the other frequency. Again, a lot of times these will be very similar depending on what you're looking at because of where the modems are located on this map may not. I mentioned last week that as you scroll over this with my mouse wheel, I've got to hit Control Scroll if I want to go in or out. That way the map doesn't scroll when I just happen to go over it and if I'm wanting to go somewhere else. So you got your map, but then again down here you've got your VTDR domain chart. This would be your outside plan again, and it's showing you that same information. And I can drag and scroll in on that and read that a little bit easier. So that's what you're looking at, is this information here, and you're looking at this distance here, your outside plant feet, when you're talking about a correlation group, because this again would be a common impairment that's common to multiple modems on the plant. So it's going to be something that it's not in the home just affecting one device, but it's out further in the plant. Maybe something in the hardline cable where you've got a squirrel chew and maybe some water's got in there, or you've got a corroded connector on some active or passive, got an issue there where you're getting this micro reflection bouncing back and forth. And any devices that are on the other side of that, where they're having to go upstream through that particular echo cavity, are going to be reporting the same in-channel frequency response and digital taps, roughly about the same. And the reason for that is that, again, what the CMTS does is it's looking at the signal as it comes in from that modem, or each individual modem, and it says you need to adjust your digital equalizers or your taps this way to compensate for that. And each modem, if it's passing through the same impairment, the same length echo cavity, is going to be adjusting its digital equalizers the same way. So therefore, these are going to be the same. You're going to be seeing the same chart right here as far as what this modem is looking like, and you're going to see the same digital taps. These taps are kind of slices of the spectrum where it's saying adjust the spectrum a little bit this way, almost like an equalizer on a stereo, right? You want the sound to be great for a particular room, so you adjust the equalizer sliders to make that sound perform well in a good room. Well, the same thing here. You're adjusting these taps so that this signal performs well in the particular conditions that it's got to go through, in which this case would be a micro-reflection, right? And as I showed before, this is what it looks like before equalization, and it tells you what's wrong with the modem, and it tells you, each one of these taps tells you a little bit of something. And you can look at the post-EQ chart, and you can see what the pre-equalization is doing. So it's evened this out, and all of your taps are down closer to where you want them to be. You want them to be really level down here, and you want all of your energy going through tap 8. But when they're not, when you've got something in this area, especially tap 9, just to the right of your main tap, you've got tap 9, that would show an in-home issue, near-home issue. This also is a lot of times in-home, more near-home issue maybe, because as you go out here, you get further in distance. Each one of these, as they get adjusted, are adjusting for a longer echo cavity. So as you get further out here, you're going to be seeing like 700, 800, 900 feet of echo. The other thing is to be aware of, in-home issues can muddy the waters a little bit. So if you've got a device that's got an in-home issue in addition to a tap out here that's above the threshold, then it's harder to put them in a correlation group because the signal's got to change. It's got to, the pre-EQ is having to adjust for two things. It's having to adjust for the in-home issue plus the longer echo cavity out in the plant. So that's just something to be aware of. All right, so that would be that kind of correlation group. And I'm going to go back to here. And what you would do on a correlation group like this, let's see, let me get rid of this. That's what I need to do. So on a correlation group like this, a lot of times you might see, if you've got a cluster of blue modems, you might see some other modems that are not showing in the correlation group. And it may be that they have an in-home issue that we can't correlate as well. So you might see, for example, you got two blue modems and you got a red modem in between. It very well may be in the same correlation group. And all you have to do is open up that modem like I just did, and you'll see that the in-channel frequency response really is very similar to the other one, just maybe a little bit different, and the digital taps may be a little bit different because it's compensating for an in-home problem. But you can usually tell as you click around that those devices really should be in the same correlation group. The algorithm can only take you so far. You've got to have a little bit of kind of smarts in how you use the application to do that. All right, so that is that type of correlation group. I also wanted to show the two new correlation groups. Now, I don't have examples in here of either of these. I'm going to show this one first, full band capture correlation group. Now, again, I don't have that in here, but one of the customers that we already have up on this particular version does have some full band capture modems that are correlated. So I pulled up a correlation group, and you can see what you get when you pull up a correlation group like that. So instead of having the in-channel frequency response and digital taps, you've got basically your spectrum that you're showing right here, and you can see you've got the spectrum kind of laid on top of each other, and they all look very similar. You've got different heights here, which doesn't matter because that's pretty normal that you'd have, I forget the term, but you've got different heights that's in your spectrum that you're seeing here. And you see that we've got a pretty significant suck out. And you look up here, if you can read, that's a little bit small. It says suck out right there. And you can see there's a little, maybe you can see there's a little shaded band right here pointing that out. But it's pretty easy to see visually as well that you've got this pretty significant suck out in the spectrum right there. So this has basically said that we've got these devices that are blue right here that all seem to be showing the same downstream spectrum impairment. We've looked at the signals from all of them. We said it looks like they all have a suck out in this particular area that's about the same, and they're all geographically close to each other. So we correlate those and display them on the map. And this is really a powerful tool. So normally, you might have to go to the customer's house to even see there's a suck out, right? If you don't have a tool like this with full band capture. And you go to that house and you see the suck out, and you look around, you're trying to fix it at that house, or you then have to go from house to house to house and try to figure out where does it start and where does it end, right? If you're going to do it that way. But here, you can kind of do the same thing and do a virtual sweep using this particular correlation group. As I see all of my devices here, let me see where it shows me the number. Yeah, so right now it's showing me items per page is 5. It says 1 out of 11. So I can increase that to, I'll go and make it 25. So now I'm showing in this table all of those, and I'm going to be showing below here. Now I'm showing all 11 kind of stacked up in here. But it does kind of show you that you still have this suck out affecting all of them. They all have very similar signatures really throughout the whole spectrum. So they're all being impacted by the same thing. And the other really cool thing about this that I really like is you can do this virtual sweep where I can pick a modem at a time. I can just click that, and now I'm looking at the spectrum for that particular device. This is a spectrum capture, so this is not live. We do capture this on a regular basis. So you can see I've got the same thing here. I've got a suck out right there. I'll close that one. I'll click the next one. Same thing, a suck out there. I'll go way up here. You can see the same thing, a suck out there. Okay, so you're seeing pretty much the same thing. And some of them are showing that we've got, I don't know if it looks like maybe a standing wave. But it's showing, I can't see. If I were to click on any of these, and I'm not going to do that because these are real customers in real places. I don't want to do that. I don't want to show the full modem screen. But if I were to click on there, I could get the full size spectrum chart and drill in on that and do the same kinds of things I can do with Spectra. Maybe I'll show that in a minute on the other instance here. But again, I've got this cluster of devices, and I've got a few devices in here that are not blue. So I can click on those and do the same thing. I do this little virtual sweep. And even though this one is not showing the correlation, I still see that suck out. The reason the algorithm is going to look at them and try to get close, right? But it may be showing that maybe there's more tilt on this one. Look at that compared to this. Maybe it's a little bit more tilt on that one. So for some reason it said that one is not in the correlation group. This one here, suck out there, right? So that is in the correlation, even though it's not showing up as blue. I can look at this red one here. That one also has a suck out. That looks flatter, right? That one was not identified as a correlated modem. This one here, that one looks flatter as well, but again, suck out in the same spot. Let's look at this yellow one. The yellow guy, suck out. Let's look at this yellow one. Okay, things look different now. So we've definitely got some tilt on this. We don't have the suck out, so this is different. This modem is different from this modem. So that tells you there's a place delineated in here where you need to start looking, depending on how your plant is going and everything, where you need to start looking for a cause. We'd want to look on the other side. Here's a green modem. I click that. That looks pretty good, right? So not seeing a suck out. This one here, another green modem, nice and flat, right? So these are definitely not in there. And go down here to this one. Looks good, right? So I've got a modem here. Looks like I've got modem here, and then things change right there. And this one, that's got a suck out. This yellow one right here, but this green one on this side of the street, probably not. Nope. And this yellow one on that side of the street, can I get to it? Can I zoom in a little bit? That yellow one, nope. So you can see how helpful this would be as far as tracking down downstream issues. This is before we identified the modems that had spectrum issues on the dashboard, and we still do that. And you can click on them one at a time, but it didn't really correlate anything as far as who's experiencing a similar problem. We just said, here's all of the problems, here's the worst ones. Now we're showing you devices that are nearby that have this similar spectrum right here. So that, I think, would be very helpful. Now this may be, I believe this may be an additional tier up from what we have now. So this may be something that would be an additional license to have. I don't have the information on that yet. So just keep that in mind, but this will be a feature that is available in this application. I just don't know yet if it will be included with the level that everybody has now. So that is something that we can certainly let you know later as we get this stuff rolled out. The other correlation group that I wanted to show was an RXMER correlation group, and we don't have that in the demo, and I don't have that in this other instance that I'm looking at here, because this would be for DOCSIS 3.1 modems, and I don't have a customer yet up that's got DOCSIS 3.1, but I can show you a couple of screenshots of what it would look like. So I think I got that right there. Yeah. So this would be the widget on the dashboard that you see here. So it shows you the node, shows you the correlation group name, the number of modems that are in that correlation group, and then it shows you the average RXMER that would be the RXMER averaged across all of the modems that are in that correlation group. It shows you that. And then as you click in either one of these correlation groups, I can't actually click on anything here, but as I do that, this is basically what pulls up. So it looks similar in that you've got the correlated modems on the map, and then you've got your RXMER chart. And as you see that line there, that would be, again, the RXMER spectrum that's showing you for all of those devices kind of overlaid on top of each other. So you can see that they're all very, very similar. It's hard to tell, but that's more than just one line. They're all kind of stacked on top of each other there. And as you look at the map, you see the blue devices that are in the correlation group. I see a lot of red devices scattered around in between those. What I'm not sure of, what I don't know yet, and we'll get an answer on this as I find out more. I don't know if those are all DOCSIS 3.1 modems or if those are just nearby modems and they're not DOCSIS 3.1, so therefore would not be part of this correlation group because there's no RXMER to correlate. Or if these would be DOCSIS 3.1 modems and it's similar to what I was just talking about, where the signal that you're getting is close but not close enough to be included in the correlation group. I don't know that yet. So I tried to get that question answered before we got on live here, and I didn't get that. So I will try to get an answer for next week, if you'll join me then, and I'll get an answer to that and maybe some other things that I haven't been able to get answered as I've talked about this. So you can see it's very similar, and that you'd want to take care of these, because if you've got this, you see some serious noise on the in the spectrum on the lower and then the upper parts of the spectrum there. I can't see what those are. Which one in here? 800, 900, can't really tell on the upper side, but you've got that noise. So you've got some kind of ingress that's under the subcarriers here in those particular areas that you want to take care of, because that would impact the performance and the speed of any devices that are DOCSIS 3.1 that would be in that area. So this would help you identify those devices that are experiencing that. And again, with the map, assuming that you can correlate all of those on the map, and again, you can click on the individual map pins and look at the RXMER for each device, and you can see if something's not in a correlation group. Let's say it's not correlated by the blue pin. You could click on it and see if it does have a similar kind of spectrum chart or RF chart. Then you can say, oh, well, this one is, or no, this one's not. So it helps you determine where your boundaries are as far as which devices are experiencing this RXMER noise issue, this ingress that's coming in. So it could be, again, just something as simple as a issue with a cable or a splitter or something like that, where ingress is getting in that's impacting lots of different customers. So that's that particular correlation group. Again, that may be something that will be an additional licensed module. So I don't have all the information on that just yet. Let's see, what else was I going to talk about? Anything else here? I was going to show you, I was going to go back to the original correlation group here. Can't remember why. Just bring this up for a second. Actually, I already talked about that. So I was saying how you could click on a device. Maybe I was going to show it. You can click on a device and pull up, even though it's not in the correlation group, you can look at the in-channel frequency response, and I can see very clearly that this device would not be in a correlation group right there, because it's got a nice flat line here, and it's not exceeding the threshold on in-home problems, which would be here, in-home, near home, and then you're further out in the plant. And as I scroll down, you see there's no in-home or outside plant feet to be looking at. So I think that's it for today. I don't see any questions. So if any questions come up in the meantime, you can always just, after the broadcast, or if you're watching this after the live broadcast, you can always just go into YouTube and type into the comment section there, and I will see the questions there and can answer them. So I'll be happy to do that for you. So again, next week I'm going to be looking at the OFDM capacity planning that we've got in there, and anything else that I have not yet talked about that I think I need to mention. I'll mention that as well. And again, any answers I might have to some things that I was not sure about and I haven't been able to get an answer yet, I will cover those things as well. So thanks for joining me. If this was helpful for you, if you enjoyed this video, please give me a thumbs up on the YouTube channel right there. And if you've not yet subscribed, go ahead and subscribe to our channel. Click the little bell and you'll be notified anytime I'm live. I will be here next week at 3 o'clock to finish up our presentation on PreEqualization Analyzer version 5. I hope to see you then. Thanks. Bye-bye.